ready to go into section 2 of chapter 8, systems of linear equation in 3 variables and their applications. In the last section we did 2 variables. We had 2 by 2 systems, 2 equations with 2 unknowns. Now we're going to have 3 by 3 systems, 3 equations with 3 variables, 3 unknowns. And our equations are going to look something like this. ax plus by plus cz, a third variable, is equal to d, where a, b, and c are not all 0. So we can't graph 3D on 2 dimensions, so we have a third axis. Notice this one is the x-axis. It's supposed to be kind of in a 3D effect, coming out like this. And then you've got the y-axis, where normally we would have the x, and the z-axis, where normally we would have the y. And the positive directions on the vertical are up, and horizontal are to the right. But for this one that's supposed to be coming out, it's coming out towards me. It would be the positive. And you can see I've set the scale. Now, 3 by 3 systems have their place in mathematics, and you can get into bigger and bigger systems. Typically by that time you're in college and you're working with matrices to help you do the work. But our solutions to a 3 by 3 system will be ordered triples, not ordered pairs, because we have to have a value for the x, the y, and the z. So we'll write them as ordered triples x, y, z, and they will solve all 3 equations with the 3 variables, 3 by 3 systems. So before we actually get to one, I kind of want to go over the basics. And first things first, think about what this is. With 3 variables, we don't have a line, we have a plane. And what we're doing is we're looking for where, with a 3 by 3 system, where the 3 planes will intersect. And they can intersect at a single point. So we're going to be looking at those types, and then we'll look at the special cases as well. But let's look at this equation, and let's see if we can come up with the idea of how to graph it. Now when we graph a linear equation in 2 variables, one way to graph it on the coordinate plane is to find the x and y intercepts. Well, what I'm going to do is I'm going to find the x, y, and z intercepts. I'm going to graph those 3 points, and those 3 points, non-collinear points, are going to determine a plane. So to find the x-intercept, you make y and z equal to 0. So if y and z are equal to 0, you see you get 3x equals 15, x is 5, so you have 5, 0, 0. To find the y-intercept, you make the x0 and the z0, kind of cover those up. Can you see it's 3y equals 15? Y is 5, so the y is 5 when these 2 are 0. To find the z-intercept, you make the x and the y 0. Can you see here that you would get negative 5z equals 15, so z is negative 3. So z is negative 3, the x and the y are both zeros. So now if I was to graph these, and by the way, when you graph an ordered triple in 3 space, the first number tells you how much to come out or how much to go back. The second number tells you how much to go right or left. The third number tells you how much to go upward or downward. So I'm going to come out 5, and then I'm not going to go to the right or left, and I'm not going to go upward or downward. It's on the x-axis. So 1, 2, 3, 4, 5, right here. I'll put a point. 0, 5, 0 is on the y-axis. It would be 0 front or back, 5 to the right, 1, 2, 3, 4, 5, and then 0 up or down. So I have this point. And then on the z-axis, this tells me again, towards me or behind, right or left, and then up or down. Well, I'm going to not go out or back. I'm not going to go right or left, but I'm going to go down 3 spots. Now, if you can picture this, and I'm going to have to see if I can draw it halfway decent. All I can really do is draw this triangle here. Now, if I was a better artist, I would probably be able to shade this in such a way that you would be able to see the 3D effect of it. And what we have is the plane that is going to contain that triangle, that triangular region. And that would be, the whole plane would be the graph of this. And remember, this is a plane, not just a triangle, but it's a plane. I can only really draw 3D on a 2-dimensional surface with limited success. Alright, now let's go over here and let's see if we have the ability to determine if an ordered triple is a solution to a system. When we were trying to do this for a 2 by 2 system with an ordered pair, We substituted the ordered pair into both equations to see if it satisfied both. Well, we're going to substitute the ordered triple, and for x, y, and z in all three equations, and if it satisfies all three, it's a solution. If it even one of the equations it doesn't satisfy, then it is not. So I have to plug in -2, -6, and 3 all the way through. Now, if I plug in, say, to the first one or the second one, and it makes it false, I don't have to go any further. So let's try this first one here. 5 times -2 minus -6 plus 3 times 3, does that equal 7? This is -10 plus 6 plus 9, does that equal 7? Let's see, -10 plus, no, it doesn't look like I get 5 is equal to 7. Well, that's not true. So I don't have to go any further. No, it is not a solution. Now let's try -1, 2, and 0. If I plug -1 in for x, 2 in for y, and 0 in for z, I would have 5 times -1 minus 2 plus 3 times 0. Does that equal -7? This is -5 minus 2 plus 0. Yep. Works for the first one. Now let's try the second one here. So this would be 3 times -1 plus 4 times 2 minus 0. Does that equal 5? So this is -3 plus 8 minus 0. Does that equal 5? Yep. That one works out okay, so we're almost there. Let's try this last one. I'm going to plug, where am I at? -1 and 2 in here. So I have 9 times -1 plus 5 times 2 plus 7 times 0. Does that equal 1? -9 plus 10 plus 0 equals 1. 1 equals 1. It checks out okay. And so for this ordered triple, yes, it is a solution.